Anila ma'am?
Yes,
Yes,
ma'am.
ma'am.
Shall we
Can
start?
we start? Yes, ma'am.
Okay, ma'am. A very good morning to everyone. I welcome you all in the second session of day 2 of AICTE ISTE 1 week online refresher program on artificial intelligence in cooperative Noma 5G network. In this session, Dr. M. Lakshmi, Professor, SRM Institute of Science and Technology with us as an eminent speaker. I welcome you, ma'am. It's my pleasure to introduce her. Dr. M. Lakshmi presently working as a professor in Department of CSE, SRM Institute of Science and Technology, and she has an experience of more than 24 years in teaching. She previously worked as a professor in Savetha University, as principal in Sri Krishna College of Technology, Coimbatore, and as a professor and dean, School of Computing, Satyabhana University, Chennai. She has completed her BE in Computer Science and Engineering from Bharati Darshan University and ME Computer Science and Engineering from Madras University and PhD from Satyabhama University in the area of wireless ad hoc networks. She has published more than 50 papers in international journals and conferences. She has organized many workshops to students, faculty, and research scholars, and also organized many national conferences and international conferences. She is currently guiding 8 research scholars, and 7 have completed PhD under her guidance. She has completed accumulative research project funded by Indira Gandhi Center for Atomic Research Kalpakkam titled Development of Data Mining Tools for Sequencing, Assembly, Deassembly of the Fuel Transfer ARM for PFBR and Identification of Failure Modes during operations. She is a DST FIST project coordinator and got a funding of 57 lakhs from DST to establish wireless sensor and IoT lab. She was the founder coordinator for Student Development Cell at Satyabhama. She has received Best Teacher Award 5 times in the year 2003, 2007, 2009, 2012 and 14 from Satyabhama University. I welcome you, ma'am. Now I would like to invite Dr. M. Lakshmi to deliver her talk on role of AI in cooperative 5G network.
Yes, thank you. So I take this opportunity to thank the professor and head of Department of ECE, Poornima College of Engineering and Technology, Dr. Garima ma'am. So I'll share my screen now. Ma'am, once again, I have some issue in sharing. Once again, ma'am. Ma'am, sharing
Yes,
option is
ma'am.
given to me. Is share screen option is given to me?
Yes, ma'am.
Yeah, it's there.
Yeah. Upper
I
arrow is
will
there on our screen. Lakshmi,
give
upper
me.
here. You just put there mouse.
But,
Yeah.
huh?
Upper arrow is there, ma'am.
No, actually, I think it's there.
Ma'am, just look upper side. There are three dots. Then there is speaker and video call, and then there's the upper arrow is there. And if you found any problem, then you can share it to me.
Ma'am, should I send the PPT to you so that you can share me?
Yeah,
Yeah, I will just forward the mail. 2 minutes.
sure, ma'am.
Ma'am, I have sent the mail.
Ma'am, you send it?
Yeah, ma'am. Yeah, ma'am.
Okay, yeah.
And, ma'am, have you received it?
Yes, ma'am.
Yeah. Okay. Thank you. Thank you. Sorry for the trouble, ma'am.
Then it's okay, ma'am. Is it visible now, ma'am?
Yeah, ma'am. Yeah, ma'am. You can put it in the slideshow mode. Yeah. Shall we start? Kindly put it in the slideshow mode so that it will be easy, visible to everyone. Yeah, thank you. Thank you. Sorry for the inconvenience. So actually the today's topic is role of artificial intelligence in 5G network, right? And nowadays we are in the world of information era where everywhere a lot of data is being shared, right? Because of the network and electronics growth, drastic growth in the devices have become very small, and the network and the data which that can be shared across others have been large. So now we are in the world of information era, and where large volume of data is being shared, and we are having wherever you turn you can hear the buzzword AI, artificial intelligence, machine learning, deep learning, big data, 5G, 6G, etc. Where when we move on further, so a lot of data will be shared. So we'll see how artificial intelligence can be applied in 5G networks for better applications. So next slide, please. So what is artificial intelligence? We all know that we are trying to mimic the human brain, right? So we make our computer to think like human. So that is what artificial intelligence. So it's basically the mechanism to incorporate human intelligence into machine through a set of rules, or we can call it as an algorithm. So AI is nothing but it is a study of training the machine. Machine may be a computer or any computing device to mimic a human brain and its thinking capability. And this focuses on three major aspects of a skill, namely, one second. Basically, learning, reasoning, and then self-correction. We all know what is learning. Learning is nothing but acquiring and learn by experience. Usually we learn by experience, but machines cannot learn by experience. What we do is we will be creating a set of rules through which the machine is made to learn by the data which it is getting. So it constantly get the data and try to learn itself by building new rules. So that is learning. Another part of the skill set which is done in the AI program is reasoning. Reasoning is choosing the right data to achieve the desired outcome, and self-correction, that is also needed, right? So learning and reasoning, if these two are done properly, and if self-correction is not done, then we will not be able to fine-tune the data, right? So based on some dissimilarities has to be removed, that is done through the self-correction. So the data sorting algorithms are called as rules are called as algorithm, which is nothing but step by step, right? So next slide, please. So artificial intelligence is the major domain. Under that we have machine learning, which is subset of artificial intelligence. Machine learning. So what is machine learning? Machine learning is nothing but the study or process which provides a system to learn automatically on its own through the experience it had, and it tries to improve accordingly without being explicitly programmed. Right, that is this one. So how it tries to learn is nothing but through the statistical models which we are creating for it. And this machine learning is a subset of artificial intelligence, and this mainly focuses on development of programs that access data to use it for themselves, to learn by themselves. So the entire process makes observation on the data to identify the possible pattern. And actually these deep machine learning algorithms are used to improve the throughput and accuracy and density of the data. And one more subset of machine learning is deep learning. So now we are using deep learning. So deep learning is nothing but it is inside the machine learning. It is a subset of machine learning where you will be using neural network to mimic the human brain like behavior. So deep learning algorithm focuses on information processing pattern maximum and a mechanism to possibly identify the pattern just like our human brain. And a deep learning, apart from that, we also have actually deep learning uses neural network, which is which learns by itself through the activation function. You might be knowing the activation function. So in neural network is nothing but combination of multiple neurons where each neuron will have a activation function and gets the input. Based on the activation function, it gives the output, and that output may be given to the next. So the difference between neural network and deep learning is, in case of neural network, we have only limited number of layers. But when we go for deep learning, we can have multiple sets of multiple layers, right? So that is why it is called as deep learning. So multiple layers can be there. And yes, slide is not shared. Is slide is not visible? Ma'am?
Ma'am?
Yeah, slide is not visible.
Okay.
Is it not visible to me, or?
Now is it visible, ma'am?
Yeah. Now it's visible. Now it's visible. So we can put it. Sorry for it. Yeah. So this slide shows how the interconnection of various components, like artificial intelligence is the bigger domain where we have machine learning inside the deep learning. Not only that, we have robotics. Everything robotics also comes under this one, and then wireless and natural language understanding. All these are all components of artificial intelligence. So next slide, please. So how can we leverage machine learning and AI for 5G? So that is what we are going to see in today's session. Yeah, fully operative and efficient 5G network cannot be complete without artificial intelligence, because the 5G enables simultaneous connection to multiple IoT devices. We know that we have many IoT devices connected together, which generate massive amount of data that must be processed by using a proper mechanism. So to process the large volume of data, AI and ML can be used. So when we use AI and ML with 5G, we can have high automation level and application based traffic steering across the network, right? So traffic can be properly routed across the network, right? Instead of flooding the traffic in all the things, so the routing can be done properly by using this AI algorithms and dynamic network slicing to address different scenario with different quality of service requirement. Based on this quality of service requirement, the network slicing can also be done. So next slide, please. So when we try to classify different ML approaches, we have next slide. So we have what machine learning, and the machine learning algorithm can be categorized into 3 types: supervised, unsupervised, and reinforcement. So this we all know. So what is supervised? Anyone? What do you mean by supervised learning? Anyone? Kindly you can unmute and give the answer. What do you mean by supervised? Yes, anyone? So supervised learning is nothing but we try to teach or train the machine by using the data that is well labeled, right? So we will be giving both the input and the expected output. So for the input, we will develop the, for any particular application, a mathematical model will be designed, and to the mathematical model, the input will be given. Not only the input, what is the expected output of that input? Input and expected output both are given as input, and the network, the mathematical model gives some output. And now the output, whatever output we got, that is the actual output, that is checked with the expected output. If both matches, then we have got the correct. Otherwise, we have to do this again. So with the inputs are corrected based on the difference between the expected and the actual output. The difference is taken into account, and the inputs are corrected, and then, sorry, not inputs, the weights of each and every nodes are corrected, and then again the input is given to check whether we are getting the expected output. The actual output and expected output has to be done. And when we try to do this, that is called as training. So training, so in supervised learning, we will try to train the network by giving the known input and the expected output. Once the known input and expected output, both whatever expected output we are getting for the given input, then it is said to be that the network is trained. Once the network is trained, then we will try to test the network by giving some unknown data and check whether these unknown data as well as the expected output for the unknown data, if we are getting the say expected output from the trained network, then we will call that particular neural network is completely trained, right? So that is what the supervised learning does. And unsupervised learning, we will not be giving, we will be just giving the data, and we'll try to make the network itself is learn by the concept of clustering and other things, right? So that is unsupervised. And reinforcement data, no input will be given. So it tries to learn by the environment, right? Like, so we can give the child's learning as a reinforcement learning. So for example, a small kid, right, so a 2 years old kid, it doesn't not know, the kid does not know that the fire, when it touches the fire, it will burn, right, or it will give some irritation feeling. But when we tell, the child will not understand. So only when he tries to go near the fire and feel the warmth of it, then he understands that it is hot and we should not go near the fire, right? So this is learning by experience. So that is what is done by reinforcement. So in reinforcement, the learning, each and every learning, the learning will be either given a reward or it will be given a punishment or something. So based on that, the learning happens. So these are all the 3 types of learning. And under supervised learning, we have classification and regression. These are all the 2 categories. So classification, some of the classifier algorithms are Navy Bayes, nearest neighborhood, SVM, KNN, etc. comes under that one. And then in under regression, we have linear regression, decision tree, etc. So under both classifications. So supervised learning, we have another thing called deep learning. Now we are going to see how deep learning can be applied with 5G for various research opportunities. So deep learning, and under deep learning, we have artificial neural network, feed-forward neural network, convolution neural network, recurrent neural network. So all these comes under this, right? So next slide, please. So next, supervised learning is nothing but whatever I told. It is a type of machine learning algorithm. The training data set is labeled, right? So you can see label data, and then it gives the learning algorithm generates a model. Next slide, please.
लेक्चर अटेंड करना है तो इलेक्ट्रॉनिक्स से लेकिन एआई समझा रहे हैं शुरू से एआई के बारे में चल रहा है आर्टिफिशियल इंटेलिजेंस का
नेक्स्ट स्लाइड is anyone is asking a question?
शुरू अभी हुआ
So here this diagram this tells supervised learning. So here
उससे ज्वाइन
so
मेरे नाम से कर लिया ना जाना फिर
mute yourself.
अच्छा ठीक
So the data is X and Y. X is nothing but the, as I told, input, Y is the output. So when this is given, the learning algorithm makes the learning algorithm is nothing but the model, whichever is given. So that model it takes, and then based on that, it gives the output, right? So that is supervised learning. And next, so under supervised learning, we have classification and regression. So classification is nothing but, next slide, please. So classification is nothing but, it has classification problems like whether the output is red or blue, disease or no disease, right? So like that we have different classification, and regression is nothing but the target variable has a discrete value such as yes or no, or it can be anything, right? So that is this thing, right? So regression and classification comes under this one. And next is unsupervised learning. So some of these supervised learning deals with different components. So the different types of supervised learning are regression, logistic regression, classification, Navy base, KNN, decision tree, and support vector mission. So the advantage of supervised learning is supervised learning allows collecting data and produces data about output from previous experiences, and it helps to optimize the performance criteria with the help of the experience. And this tries to solve the real world computation problem. So wherever we try to solve the real world computation problem, there will be using supervised learning. And the disadvantage of this is big data can be challenging. So when we try to classify a very big data, large volume of data, then this becomes a challenging. And training the supervised learning needs a lot of computation time. So it requires the time complexity is more here. And next slide. So next is unsupervised learning. So unsupervised learning is the training of machine using information that is neither classified nor labeled, and allowing the algorithm to act on that information without any guidance. So here the task of machine is to group the unsorted information according to similarities, patterns and differences without any prior training of data. So prior training will not be given. So it tries to classify the data based on the similarities or some pattern or some differences, something, right? So unlike supervised learning, here there will not be any guidance that will be help the network to get trained, and that will be not be given to the machine. So the machine is restricted to find the hidden structure in unlabeled data by itself. That is the major thing in supervised. So when you talk about supervised learning, the unsupervised learning, this is category, it classified into two categories. One is clustering, another one is association. So clustering is nothing but where you discover the inherent group in the data, such as grouping the customer based on the purchase behavior, or grouping the customer based on the age, or grouping the customer based on the frequency of purchase. All these can be done by using the concept of clustering. And what is association is? Association is also one type of unsupervised learning mechanism, where the association rule learning problem is to discover that the large portion of data, right, when we try to build the association. So for example, in the marketing, right, so when a person tries to purchase something related to that, what are all the other things purchased in associate with that, that is the association. For example, during the festival time, for example, if it is a Diwali, then the purchase pattern will be, people will be purchasing sweets, and then clothes, crackers, etc. Right? So the in the shops, so whatever will be purchased by the particular or a set of customer, that will be kept in the front of the shop, right? So for the analyzing the components which will be purchased, that will be using association. So the same association can also be applied, clustering, association, and all these techniques can be applied in the machine learning also, where sorry, in the 5G also, to find the pattern of this thing, or the traffic of the where high traffic is there, and what is the pattern of the customer, all for marketing as well as for network monitoring, etc. This can be applied. And next is reinforcing. Next slide, please. Next slide, please. So reinforcing is nothing but the the agent acts in an environment in order to maximize the reward and minimize the penalty. So as I told, so the system will, or the algorithm will try to learn itself by the environment. So unlike supervised learning, no data is provided to the agent. The agent itself take action or sequence of action, whether right or wrong, to perform it the task, and it tries to learn by itself. So next slide. And the next slide shows the difference of all these three: supervised learning, and here it learns by using the labeled data; unsupervised, unlabeled data without any guidance, and this works on interacting with the environment, reinforcement data, right? So here when you talk about type of data, supervised will have labeled data, unsupervised, unlabeled, and then reinforcement, no predefined data. So types of problem that can be solved here are regression and classification, in unsupervised association and clustering, and reinforcement, exploitation or exploration. These two are right, and supervision is there in the supervised ML, and unsupervised and reinforcement, there is no supervision. So what are all the algorithms that can be used is, in supervised, as I said earlier, linear regression, logistic regression, support vector machine, K nearest neighborhood, etc. can be used. And when it comes to unsupervised machine learning, it is K-means or C-means or a priori algorithm. All these can be used. And if it is reinforcement, then we have Q-learning algorithm and SHASH. Okay, so the aim of this is to calculate the outcome, discover underlying patterns, right? For that, if we want to know the unknown patterns, then unsupervised learning can be used. And to see the series of action, reinforcement learning can be used. And machine learning, important for 5G system. So existing 4G uses IP protocol, and here the broadband connectivity to transmit is very, very inefficient. So because 4G uses orthogonal. That is, it uses CDMA or TDMA or FDMA for multiple access. So since the multiple access is the major concept, why we are moving on to the 5G. Since 4G uses only all these orthogonal multiple access schemes, so the problem with that is if more number of users are because now each and everybody is having multiple devices, and all these devices we are connecting to the net. So if number of users are becoming more or number of devices becoming more, then the service providing will be the problem. That's why we are moving towards 5G and beyond 5G. So AI and ML allows the 5G network to be predictive and more proactive, and which is very, very essential to make it functional. So by integrating machine learning into the 5G technology, intelligent base station will be able to make decision by themselves, and the mobile devices will be able to create dynamically adaptable cluster based on the pre-learned data. So this will improve the efficiency, latency, reliability of the network application. So introducing AI and ML in mobile communication. Next slide. So what for we are moving with AI is basically to improve a better quality of experience. So quality of experience is nothing but how the user feels with the connection or something, right? So the quality of experience has to be improved. So that is a major concern here. So AI is expected to help providers further improve the customer experience in many ways. So improving network quality, providing personalized services, and AI will also be recoup the investment on the communication service providers for making in their network to switch to 5G, right? So communication service providers investment can be recouped, and here lowering the operational cost and ensuring returns on network investment are the key priority that service providers are looking. So that's why artificial intelligence comes into picture, and network intelligence and automations are crucial to evolve 5G, IoT, and industrial digitalization. Everybody knows this. As 5G technology develops, operators will need to increase their network capacity. So the added capacity brings additional complexity also. And the factors, next slide, the factors contributing to a full and efficient AI integration into mobile network is network operability. So these are all this slide shows the various opportunities. So intelligent and smart application and service, predictive network characteristics. So what are all the characteristics and the quality of service parameters that can be predicted, and massive data availability in the level of user, network, and service, right? So there we can apply that, and advanced and efficient algorithm into AI learning, distributed and affordable computing resources. So these are all some of the factors contributing to the AI, which can be integrated into the mobile network. And next one is next thing, right? Apart from AI and ML, next concept, which next slide please, which is more prevalent in 5G network is data. Big data is a prerequisite for integrating AI in the mobile network, because a large volume of data will be shared across the network. So integration of intelligent algorithm and learning approaches needs the availability of big data sets, which represent the starting point. So the classification of different big data sources are needed, right? So three big source of data is wireless data, and social network aware data, and then cloud data. Next slide. So next slide shows the difference between all these data. So social data, mobile network data, cloud data, and then wireless data. So this tells when mission-to-mission communication, mobile social network communication, and cloud stores communication. So how the different types of communication happens between the user and the system, right? So the user can do a personal communication or a social communication, that is in the social media, as well as when he tries to put something in the cloud, right? So each operations will have different set of operations to be carried out. So these data plays a major role here. Next slide, please. So when you talk about wireless data, the wireless data comprises of all these things, right? The infrastructure data. So infrastructure data is nothing but the like all your towers, base stations, access points, etc. And the location of it or the capability, equipment holders, etc. All these are all infrastructure data, and a key performance indicator like the quality of service parameters, everything will be included in key performance indicator like data traffic, data throughput, end-to-end delay, quality of experience, jitter, bit, error rate, etc. So all QoS parameter comes under this key performance indicator, and call detailed records are also very important. So for each and every call, session starting date, ending date, inter-arrival time, holding time, sender, receiver, etc. all the data need to be taken into consideration, and radio information data also like signal, power, frequency, spectrum, modulation, service, base station. So all these are all comprises of wireless data. So so the data plays a major role. So this is, see, if each and every individual is taken into consideration, individual will generate lot of data. When you take a particular cell or a particular region, a large volume of data is generated, right? So not only the wireless data, apart from that, many other data like social data, social network data, and then cloud data are also prevalent there. So when you talk about social data, the penetration of mobile internet into our daily life and behaviors makes convenient multimedia communication easily accessible for anyone, independently of the age or social level, right? So whatever may be the age or whatever the social level, everybody is uploading or downloading a lot of information across the network, right? So even with the small mobile device, also to process lot of data in the social media, lot of data is being uploaded or it being downloaded daily across the globe. So a large volume of data is managing the large volume of social data is again a challenge. And here if it is expected to grow, that is the major constraint here. So the mobile operator, network operator can exploit such data to build a aware wireless concept. For example, so when you talk about social network data, so the social network data are nothing but the data for example, I will give an example for this social network data. So in case of tourist sites, right? Tourist sites where a lot of tourists will be visiting, if the bandwidth is kept high there, then lot of data will be put in the they will use that bandwidth to upload or share their experiences in the social media with a high quality of service, even if they have prepaid or postpaid, whatever it is. So that is another thing. And another one is social media big data source to AI learning framework, which illustrate the most promising expected AI application like mobile caching, drone-based mobile base station placement, or radio resource allocation. So all these are all. And next is cloud data. So cloud data is one of the major cause for the partition of data, which is tsunamied in the mobile network for transmission of multimedia content stored in the cloud server. So large volume of data is stored in the cloud server. Further, it was found that most content transfer over the internet are based on its popularity. It is possible, therefore, to reduce the traffic of the system by exploiting the user preference for special cloud content. For example, the most popular videos for a specific geographic region can be pre-cached at the edge servers. Instead of putting in the cloud server, it can be put at the edge server so that no real-time backhaul data downloading is needed for frequent request. And in addition, individual user preference for specific multimedia content can also be used to predict the user feature content demand, based on which the network operator can perform a pre-fetching or recommendation action. So for data management, right, whether it may be a wireless data or social data or social network data or cloud data, there we can apply the artificial intelligence or machine learning or deep learning concept, so that the minimal storage or retrieval of data. So if it is a cloud data, repeatedly storing the same content again and again, some mechanism can be done so that the repeated storage can be avoided. So next is the main goal and the component of 5G. Next slide, please. The deployment 5G seeks to provide high throughput and ultra low communication latency to improve the user's quality of experience. And to meet this requirement, actually the 5G targets three evolution axes, namely in the field. Three major field where 5G is targets is autonomous car, industrial automation, smart manufacturing, that is Industry 4.20. And next is virtual reality, health, e-health are also the other places where 5G plays a major role. Next slide, please. Next slide. And when you talk about the component of 5G, three major components of 5G are there. Next slide. Enhanced mobile broadband, that is EMBB, which allows for new bandwidth hungry applications with extreme high data rate demand over a uniform coverage area. So where you will be having the enhanced mobile broadband is where it is needed is for all the video streaming applications like AR, VR, ultra high definition video streaming, right? Wherever video streaming is needed, there enhanced mobile broadband. Next slide. Broadband is required. And next is massive mission type communication, MMTC. So here the key characteristic of a 5G communication service is a scalable connectivity, demand for expanding the number of wireless device with efficient transmission of small amount of data over expanded average coverage area. Like for example, applications like broad area network, smart homes, IoT and drone delivery will generate this type of traffic. So massive mission type communication comes into picture there. And here this MMTC must be able to support massive user and other users that would appear in future, right? So that is the application of one of the component of 5G. And the last thing is ultra reliable low latency communication, URLLC. So here this is another major component of 5G. So connected healthcare, remote surgery, mission critical application, autonomous driving, unmanned aerial vehicle, vehicle to vehicle communication, high-speed train connectivity, smart industrial application. So these application prioritize reliability. Reliability is major thing, and low latency. Delay should be very less, and mobility over different data rates. So these are all the major three components and the key challenges. Next slide. And the fifth generation 5G use cases, when you talk about enhanced mobile broadband, we have virtual reality and gigahertz speeds, autonomous system, etc. comes under that one. And when you talk about the second component, mission type, smart logistic and smart city, those two comes under, those two are the use cases which comes under this. And remote surgery and autonomous vehicle comes under the ultra reliable low. Next slide, please. Next slide. Next slide. This gives the 5 challenges, and this is the use cases for the major components of 5G. Next. Next is limitation of ML for 5G communication. So ML's limitation is data. So high quality data is essential, and the type of data is crucial factor when deciding which type of learning to use. So next slide, please. ML is only good for as the data it receives. And here hyperparameter selection, that is hyperparameter tuning, is the major things in the machine learning algorithm. The parameters has to be tuned. That is all the inputs has to be tuned properly and weights has to be tuned properly, because only if the hyperparameters are tuned properly, then the training will be proper in case of machine learning algorithm. And these values must be selected carefully because they influence the, next slide, influence the eventual parameter that are updated from the learning outcome. So that is the major thing. And next is interpretability versus accuracy. So this is the major another limitation from the stakeholder standpoint. The complex integration between independent variable can be difficult to understand and might not always make the business. So the trade-off must be between interpreting data and the accuracy. So machine learning has some limitations because 5G, when 5G is concerned, it takes a lot of large volume of data and massive computation is required. So machine learning has all these limitations. Privacy and accuracy is another limitations of that one. Next slide. So a classification of major enabling technology. So 5G enabling technology, if we take it, can be divided into 2 types: system level and network level. And system level, so we have 4 things. One is spectrum utilization. So actually, where the research, where the AI can be applied on all on these things that I have mentioned here. So spectrum utilization. So under spectrum utilization, allocation of spectrum, we can use AI algorithms, carrier aggregation, millimeter waves. So and the next is spectrum efficiency issue, where massive MMO, channel modeling, signal waveforms, multiple access, and channel coding. And network densification, where we have ultra dense network, cloud-based radio access network. And energy efficiency, when you talk about energy efficiency, so powered and RF powered energy harvesting network can be utilized, and then cellular partitioning. So there are different things. And then when you talk about network level, network architecture, software defined network or NFV, network slicing, mobile edge computing, self-organizing network, device to device communication, fog computing, all these comes under this one. So the classification of major enabling technology of 5G systems and network. Next slide, please. So 5G and the purpose of AI and ML within wireless. This enables simultaneous connection to multiple IoT device and generate large amount of data that must be processed. And here the challenge which we have here are identifying the dynamic change and forecast the user distribution, right? So by analyzing the historical data. So what is meant by historical data is nothing but the previously the pattern, right? So by checking the last 5 years, how much data is being used, and how much volume of data, how many users, all these things. The next 1 year or 2 years can be predicted, right? So that is one of the things. So identifying the dynamic change and forecast the user distribution, how many user will be there, and then forecast the peak traffic, resource utilization, application type, and optimize and fine tune the network parameter. So for capacity expansion. So these are all the some of the areas where we can apply AI and ML, and eliminate the coverage holes by measuring the interference and using intersite distance information. Because when you talk about 5G allows interference, right? So identifying the coverage holes, AI can be applied, and high level of automation from the distributed ML and AI architecture at the network edge, application based traffic steering, dynamic network slicing, ANML. So all these can be, and we will see the learning approaches. We have seen 3 learning. One is supervised, unsupervised, and then next slide, please. When you apply machine learning for the 5G application, on which areas, based on the literature, I have taken this. So what are all the algorithms that can be applied for a particular area of research? So this will be helpful for the researchers to use a particular algorithm for the particular application. So when we take supervised learning, under supervised learning, SVM is used for mostly in the according to the literature. They used SVM for path loss prediction model. So identifying the path loss in the urban environment, they used this. And ML and statistical logical regression technique, they used to identify the dynamic frequency and bandwidth allocation in self-organized LTE dense small cell deployment. And neural network based, so for neural network based channel learning to interfere unobservable channel state information from an observed channel. So from observed channel, unobserved channel state information can be got through this neural network based approximation, supervised ML framework. So adjusting the time duplex division by uplink and downlink configuration. So this is some of the application. Next is unsupervised learning. Next slide, please. So under unsupervised learning, the algorithms which are used is k-means clustering, Gaussian mixture model, expectation maximization, hierarchical clustering, and unsupervised soft clustering ML framework, affinity propagation. These are all the different learning models and the application of it that is given in this slide. Next slide. Next is reinforcement learning. So reinforcement learning algorithm, what is the algorithm which are all used is long short-term memory, LSTM. LSTM is a very famous deep learning algorithm. So reinforcement learning along with LSTM can be applied, and gradient follower, modified MRE and MBM, modified Bush and Mostler, and reinforcement learning with network assisted feedback. These are all some of the learning models applied, and where it is applied, that is given in the last column. And whatever we have seen so far is machine learning algorithm. So the drawback of machine learning algorithm is machine learning algorithm, actually when we apply machine learning algorithm, the feature extraction, the identification of feature has to be done manually by the user, right? So we have to identify the features properly. If the features are not identified properly, then the training will not be complete and the expected output may not be received properly. So that is the major drawback of machine learning. That's why we are moving into the deep learning. So when you move to deep learning, the advantage is the feature extraction is done by the deep learning model itself. So the DLL model try to identify the feature so that any hidden feature can also be extracted. So whichever feature which we have not identified, those feature can also be identified by the deep learning model. That's why we are moving on to deep learning model. So deep learning models can be applied in the mobile network in the system level in different layers, right? So we can see TCP, that is 4 layers are there, physical layer, physical and data link layer, network layer, and then upper layer. So physical, where it can be applied, like interference, alignment, modulation, classification, signal detection, anti-jamming, error correction, all these. And when you talk about data link, channel resource allocation for NOMA, and then traffic prediction, scheduling, link evaluation, link status prediction. And when it is network layer, routing, route establishment and route optimization in both the places. And if it is an upper layer, then session scheduling, OS resource management, radio resource management, handover prediction, all these areas can be applied. And when you talk about network, security is one of the major constraints. So security has to be taken into consideration. So network security and here flow indication, that is traffic identification, application identification, both, right? For that, as well as intrusion detection, we can apply the deep learning models. So various deep learning algorithms in different layers for which application can be applied, that is given in this slide. Next slide, please. So actually the 3 pillars for integrating AI in the network lifecycle is workflow intelligence, dimension of intelligence, and subsystem intelligence. So workflow intelligence is nothing but planning, deployment, maintenance, optimization, and then optimization, and then service providing. So it is a cycle, and it's all the places AI can be applied, as well as in the dimension of intelligence. So demand mapping, data collection, analysis, decision, action, implementation, there it can be applied. And here when it comes to the subsystem, in the subsystem for all the network element management system and all these places, a subsystem intelligence can be applied. Next slide, please. Integrating AI and ML in the planning process. So this next planning process, it is shown here. So here zero touch network and service management. So to optimize or control manage, there are 3 more desired cases, namely radio resource management for network slicing, and end-to-end network service design automation, end-to-end fault detection and recovery. Next slide, please. So integration of AI, this is how we can integrate AI and ML in the planning process of mobile network, right? Knowledge exploration, knowledge discovery, data acquisition, and pre-processing. Right, so actually here data acquisition and pre-processing is the first stage, where the collected data is properly processed, and then knowledge discovery comes, where we'll be using all the learning algorithms like classification algorithm, clustering, all the learning algorithms will be used, and based on that learning algorithm we'll be doing the network operation, right? So the capacity planning is based on the data. So how much volume of users are there, based on that capacity planning, and then network operation is carried out. Next slide. So here intelligence in SDN, this is for SDN and NFV and network control. So we have 5 layers here. Basic layer, core layer, application platform layer, application layer, and solution layer, right? So when you talk about basic layer, so the basic layer, it provides support in data calculation and a network for intelligent plane. And the data here is whatever data we have in the Blake is the big data, and it needs network infrastructure, user profile data, everything comes under this base layer. And next is the core layer. Core layer, it provides intelligent algorithm in the intelligence plane. Right, so here we have intelligent algorithm as neural network algorithm, deep learning, brain inspired intelligence, and SWAM intelligence, and that comes under core layer. And next is platform layer. Platform layer, we have it provides intelligence plane for the realization of the intelligent logistic of AI ability, and where we have machine learning, mission thinking, mission understanding, intelligent control, and mission perception. And next comes the application and terminal layer. So this provides the ability of modular realization of function needed by the solution layer. And here the user portrayed the flow control, the load balancing, and then depth perception, routing, security, energy saving, etc. is taken into consideration here. And these realization may be in software or hardware using the ability of perception, thinking, and action, and provided by the platform layer. Next comes the solution layer. It is in charge of designing flexible policies and related activities related to satisfy the requirement to operate or manage the network element, the network management system. So these are all the some of the this thing, right? So next slide, please. Some of the applications of next slide, next slide, next slide, next, next, next. Yes, application. Thank you. So some of the applications are machine learning and artificial intelligence can assist wireless operator to overcome the challenges like forecast the peak traffic, resource utilization, all these things. And that is now we'll move on to the deep learning model. So deep learning is nothing but a set of machine learning which uses unsupervised, supervised, as well as reinforcement learning. All these three can be applied. And the major backbone which is used in deep learning model is a neural network. And it facilitates the decision making and classification of data using various algorithms to obtain high accuracy and in-depth results with the little or no human either with little human intervention or with no human intervention. And machine learning algorithms are designed to learn by understanding the labeled data based on the produced output. However, in deep learning algorithm, it do not require human interaction itself. Deep learning does not need human interaction on the because you have different layers. That's why it is called as deep, multiple or nested layers, which will process the data through hierarchies and learn distinct features while learning from its error, right? So that's why I told the difference, the drawback of machine learning is the features has to be identified by the user or by the programmer. But in case of deep learning, the features will be identified by the network itself or by the model itself. How it identifies, because it has multiple layers, and without human interaction, these nested layer process the data with different hierarchies and it tries to learn the distinct features. So even if some features are missed out, it will be identified by the algorithm itself. That's why we are moving to the deep learning. But the drawback of deep learning is it needs a large computation power, right? So only with GPUs, if you have a large volume of data or if you have a large scientific data to be processed, then normal system is not possible for deep learning models. We need to use GPU system for processing the deep learning models. That is the drawback of it. But since Now GPU is available and we can use a GPU power through the cloud. Even your Google is giving a GPU through the Colab. Through Colab platform, we can use the GPU. So massive computation can be done to some extent by using the GPU, which is available as a virtual machine in the Google Colab. And here, when you talk about the 5G research using deep learning, so here the research topics that are taken into consideration are channel decoding, massive multiple input and multiple output, because when you talk about 4G we have multiple input, multiple output devices, but when it is comes to 5G, massive amount of MIMO devices are coming into picture. And here on the multiple access scheme which is used is NOMA is a, but in case of 5G, orthogonal multiple access is used, but here it is NOMA, and because it allows interference and then it rectifies it. That is a concept of multiple access here. And then resource allocation is major thing, and then security. These are all the 5 major things which I have taken. And the deep learning models which are all used here is DRL is nothing but deep reinforcement learning model. DNN is deep neural network model. DNN has 2 types. One is convolution neural network and recurrent convolution neural network. So when you talk about convolution neural network, mostly for image processing and processing the image, convolution neural network will be used. And RNN is recurrent neural network. So when we want to process sequential data, so for processing sequential data, recurrent neural network is used. So these 2 can be applied for the 5G also. So next slide. So when we take all these 5 components, right, like channel decoding, massive MIMO, that is channel decoding is low priority, low density parity check, LDPC, low density parity check. And then massive MIMO, multiple access, NOMA, resource allocation, security, all these things, all the DRL, DNN, CN, RNN can be applied. So next slide, please. So deep learning models, we'll see one by one model where it is applied. So the tabular form shows that out of the 3 models which we saw on the previous slide, CNN is applied for LDPC, massive MIMO, and then resource allocation and security. All these we can use CNN. And RNN is for massive MIMO, NOMA, resource allocation, and then security. And if it is DRL is applied only for resource allocation, right? So these are all the learning algorithm. So this tabular form tells the learning DL models which can be applied for this thing based on the literature. It is given here. So DRL is nothing but deep reinforcement learning, which follows the idea of learning by interacting. So it learns by interacting. Reinforcement learning learns not by being told what action to take, but by discovering for itself what action produce the greatest reward through a simple trial and error concept. So it uses the trial and error concept. There are 2 components in reinforcement learning, the agent and the environment. So agent learns from the environment and it fine-tune itself. So we have 2 software components there. One is agent, another software component is the environment. So DRL incorporates the concepts in reinforcement learning as well as deep neural network, so that the agents are self-sufficient. That is the software code written for agent or self-sufficient. Since this DRL replaces the tabular method of estimating state value with functional approximation, right? So when you use this algorithm, you may be knowing it. And DRL is mostly, this tells that DRL is used in resource allocation. So you can see in the tabular form, DRL is only used for resource allocation. So DRL framework are generally used in resource allocation, since resource allocation focuses on optimization. So since we need to optimize it, DRL is used. And the DRL network slicing architecture, it can also be used to improve the quality of service parameter, like allocating resources to minimize the energy, right? So there also it can be obtained. And the if it is the radio access network, the DRL applied to design the state, action, and reward to allocate the resource block. How to allocate the resource block? Resource block is nothing but a particular the frequency band, the time, and all these things is called as a resource block. So how to allocate the resource block? The agent estimate the optimal resource block and the amount of our state using the information in the slice as a state, and controls the resource block allocation to satisfy the requirement, right? So so DRL deep this is used in the resource allocation. Next slide, please. Next slide. Next slide. And next is DNN. Next. Next, please. That is deep neural network, convolution neural network. A convolution neural network, as I told, mostly it uses only images and videos. So for image classification and identification of image recognition, all computer vision, mostly there we'll be using CNN. Since the basic, the CNN is composed of 3 layers, right? So it has 3 layers like convolution layer, pooling layer, and fully connected layer. So convolution layer is the one which extracts the high level features through the means of filter. So what is a filter is nothing but it is defined as an n cross m grid of numbers that are multiplied with a number representing the pixel value of original image. And these filters are applied throughout the image in the video to extract the dominant feature and reduces the data redundancy using the next layer. Next layer is nothing but the pooling layer. So the pooling layer will compress the extracted information and it tries to categorize one image to be processed in the next layer. That could be the multi-layer perceptron or convolution layer. So actually what we use is we'll be using 2 types of pooling. One is max pooling or average pooling layer. And this try to reduce the spatial size and decrease the computational power to process the data. And last is the last layer is fully connected layer. We'll learn non-linear combination of high-level features and they flatten the image into column vector and used as an input for training and future iteration. So here there is also another layer called dropout layer, which is used as a regulation technique to reduce the overfitting. So overfitting is one of the major problem in CNN. So to try to avoid that overfitting, we are using the dropout layer. And the dropout layer is also a fully connected layer, and it's also possible to use dropout after the max pooling layer, creating image noise augmentation. So actually CNN is mostly used for image processing. That can also be used here also. And here when you, next slide please. Actually CNN is also used in 5G to study LDPC coding, massive memo, resource allocation, and security. That's what our previous tabular form we studied that. And in 5G security is another component. So where CNN can also be used to detect network anomalies, that is what are all the anomalies there, and compare to see if it outperform. So by using the learning model like Navy base, random forest, random tree, SVM, etc. So next is recurrent neural network. Next slide, please. So recurrent neural network are next please. Recurrent neural network are different from CNN, and they are generally used for, mostly it is used for text and speech analysis. So it I told no, it's used for sequential data. So sequential set of text and speech data to analyze that RNN is used. So it has the ability to learn based on the past instance of itself and predict the future. And it is capable to process a sequence of input. And that's what it is used for, processing that one. And the disadvantage of RNN is that gradient vanishing and exploding problem. These are all the two differences. That's why we are going in for LSTM. LSTM is long short-term memory network. And this LSTM specializes in processing and predicting time slice, time lag of unknown duration using three types of gate like input, forget, and output gate. And next. And this LSTM has a diverse reach, and it is used for massive memo, multiple access, resource allocation, and security. LSTM is also used in resource allocation as well. Next slide. So we'll see a low density LDPC research using, next slide, please. Next slide. Yeah, here you can see the LDPC research using deep learning. So blind LTPC code identification, CNN, FNN is nothing but CNN is convolution neural network. FNN is feed forward neural network. And ANN is artificial neural network. It is a normal, like it can be a feed forward or a thing. And DNN is deep learning neural network, right? So these are all the DNN models which is applied for LDPC result. And some of this I have taken from the literature and the papers based on the the papers where they use these deep learning model to get the result, right? So blind LTPC code identification for optimization based coding decoding algorithm for hardware architecture, FNN is used. Comparison of traditional coding to DL based decoding, ANN and DNN are used. Next. So these are all some of the models which are all applied. Next slide, please. Next. And massive memo. Massive memo is, we all know that it is multiple input, multiple output. This expands by adding a much large number of antennas at the base station. And this memo uses multiple antennas at the transmitter and receiver side, right? So that all these we know. So it will also make 5G network more reliant against interference and jamming that the current network experience. So the challenge with massive MIMO is finding new deployment scenario, reducing internal power consumption to achieve total energy reduction, the acquisition and synchronization for all the newly joined terminal, and the exploitation of extra degree of freedom provided by the massive number of antennas. So DL can be utilized to improve the, so where you can apply DL in massive MIMO is it can be utilized to improve the localization, solve the non-convex optimization problem in power control, and then exploit CSI, that is channel state information feedback for an accurate estimation of channel and direction of arrival estimation. There DL can be, deep learning models can be applied. Next slide, please. And the most prevalent DL architecture used in massive MIMO is deep learning neural network, and then CNN, where both localization and channel state informations are important because the channel property is a commercial communication link provided information on how the signal propagates. The information can then be used for channel estimation, which is required to compensate for any distortion. Next slide, please. The concept of optimizing channel resource is used when utilized a 2D and 3D CNN network with a ReLU activation function to learn the non-linear structural characteristic of the channel. Next slide. Next, yeah. So here this this table tells that the various DL models applied and the research task for different result task. So estimation of CSI, that is channel state information, estimation of channel state information, millimeter wave band. So there you will be using DNN and CNN, and downlink of multiple input, multiple output, NOMA, pre-coding and SI siding, Wi-Fi positioning, improving localization. You will be using CNN, and MLP is nothing but multi-layer perceptron. Multi-layer perceptron is like a neural network with different layers only. Next slide. Next also tells the various algorithms which can be applied for different research tasks, like channel estimation and DOA estimation. So DOA is nothing but direction of arrival estimation. So there we'll be using DNN, CNN, LSTM. LSTM is a long short-term memory. It is an extension of RNN, and there we'll be applying this. And it can also be used if power control and solve non-convex problem. Next slide. Next slide. So here CNN model is used. Next is non-orthogonal multiple access. So by exploiting different power levels, NOMA aims to serve multiple users using the same time and frequency. And since multiple are the key features of 5G, the inclusion of NOMA always has to be incorporated with MIMO. So here is an effective mechanism to accommodate high number of users without the spectrum increase, right? So here, here we can see there are two types of regimes. One is power-based and code-based. Next slide, please. So for non-orthogonal multiple access, so the next slide, please. Next slide. Next slide, please. Slide. Yeah. This tells the various algorithms, right? DL models that can be applied. Next slide. Next. So these are all the various models which can be applied for NOMA. And then resource allocation. So resource allocation is one of the process of mining and manning and assigning resources in the resource and to reach the most strategic solution. And 5G can be summed up as assessment purpose. And here we have DL. How DL can be used for resource allocation is mainly for optimization of resource usage, right? For to optimize it, this can be used. And here on the next slide, please. This tabular form tells that what all the things can be used, right? So DRL, that is deep reinforcement learning, deep neural network, and convolutional neural network. These three can be used, and as well as LSTM feed forward. Next, LSTM and feed forward network can also be used. So basic is used and research task that is given in the thing. And last one is security. Security is very, very important. And this tells that the algorithms which are all used for the security, right? For detection of specific wireless intrusion, classification of jamming attacks, and detection of anonymous network traffic, analyze network traffic, the CNN, LSTM, feed forward neural network, DBN is nothing but deep belief network. Deep belief network can also be used, right? And these are all the top 5 innovations. So where 5G is applied is in sports, virtual reality, augmented reality, live performance, game streaming, online singing, self-driving cars, wireless home, low power scanner, public safety and infrastructure, healthcare. And thank you. Next slide. Yeah. Thank you. Any queries?
Yes, all the participants are requested to ask the queries. If they have any query, they can ask directly. Unmute your microphone. Yes, any participant, any query from the participant side? I think, ma'am, there is no queries. So now we can wind up the session. I request to all of you to switch on your camera for a group photograph. Kindly switch on your camera for the group photograph. And participants are requested to mute your microphone. There is a disturbance from the participant side. Yes.
Thank you, everyone.
Thank you, everyone.
Thank you,
ma'am. Yes.
Continue.
Thank you, ma'am.
Next session will start at 1:45.